All right, so today we're going to look at how we can actually interface, communicate with the data in our database, on SQL Server using C#. So we're going to construct, we're going to build a very simple C# .NET application in WinForms, primarily so that we can actually interface with it. So we can just create a button and click it, and stuff will happen actually. So as this lesson goes, it's going to be pretty simple overview of how to create a project, how to align, construct your classes, where to put things, so we can actually talk to the SQL Server, get the data out, and execute execute a store procedure, for example, or get, execute a SQL statement. So for some of you guys that'll be pretty boring, but I will mention Entity Framework a little. No, it's not kind of really mention it in any way. But next week we're going to look at Entity Framework, which is going to be a little bit more interesting, and also going to explain why we don't use Entity Framework here. All right, so let's start by actually defining what we're going to do. We've got this database called the VentureWorks, and it's on my local server, but there's no restrictions. We can actually communicate with any server on internet or on a network. So by just providing an IP address of that server, we can connect to it. So it's exactly the same process as connected to a local server. All right, so we've got this VentureWorks database, and there's a table called products that I want to do something with. So first of all, I'm going to create a method, create a data adapter. We call them data adapters because that's how we kind of communicate with the SQL Server within C#. So I'll create a data adapter from scratch. I'm not going to use any built-in sort of widgets that are available to us in Visual Studio or .NET Framework, apart from SQL client class, which is part of the framework. Okay, so I'm going to get all the products out of it, getting product ID, name, product number, and a color, and also create a store procedure, and to insert a new product in there and get this new ID. Right, so let's begin. First of all, let's go and create a project. I'm going to put it just in my projects, and I'm going to call it test app. And that's going to be my WinForms application. It's pretty basic. Okay, so WinForms application, so just user interface for it. So how we would normally sort of arrange all our classes and within the application or solution is we would have a user interface completely separated from data adapter. So we would never actually talk to the SQL Server or any of our data communications or classes from either user interface, or if we're working with web applications, we don't talk to our databases effectively directly from that project. We always use so-called business logic adapters or data adapters. Similar like in Linux, we have common data, which is supposed to encapsulate all the all the communication with databases and how we actually represent that data to C# in form of classes. So what I would do is I will go and create a new project, add new project, and it's just going to be a class library. So it means that it's not going to do anything else apart from just being a collection of classes. So that will compile into DLL, and we can basically reference that DLL from any application, from any project. I'm going to call this business logic, because that's what it is. Ah! There is he. Okay. Sorry, it opened up as a Visual Basic. Jesus Christ. Why? Right. Yeah, that's better. Okay, so we just do exactly the same thing, and business logic. Okay, so in here, we'll go and look at our database itself, or we can kind of, well, already see how we can, how we can lay out different classes in that business logic library. So we've got schemas within our database: human resources, person, product, production, and so on. So how about we go and actually try to replicate similar schema in our business logic? So, the code that we can see in our project, in .NET project, kind of reflects to what we actually see in the database. It's quite important so you can follow the code instead of, static classes being pretty much everywhere around. Okay, so I'm going to create a folder called Human Resources in here, and person, and so on. And I will actually create classes that will allow me to interface with my database in those folders. And I can also go down and organize it even better by, with the human resources, for example, we can, put some classes to do with, let's say, hiring in one place and so on. So that just basically means that we've got a very good structure within the business logic. As it grows, some of you may know, like for example, in common data, we've got stuff pretty much laying around everywhere. And it's now become quite difficult to follow where the stuff is unless you know what you're looking for. So if you keep the structure fairly good to begin with, it's going to be a lot easier to work with that business logic going forward. All right, so since we're working with production, with products, just create a folder production, and I'm going to create my product class in there. So what I'm going to do is I'm actually going to represent product there as a class, effectively. So I'll create a class. Product, and I'll literally basically just define what that class will contain. Public string, I think we'll have, or public int, product ID, I think it's name as well, yeah, so name. Public string and product number. And color, right? There's no color in here. Oh, there's color in there. Okay, color. So that's basically what every single product class or object will actually contain, those fields. Now, what I'm going to do is I want to go to the database and, retrieve the data from it. So to do that, I need two things. I need a connection string to the database, so I know how to connect to it, and basically create a method that will retrieve this data. So I will supply SQL statement to that, and that will convert the result into a list of products. Okay, so I've got this code already ready, so I don't have to write this again, but I'll walk you through what it does. Right, so I'm using SQL connection, which is part of the .NET System Data SQL Client namespace, which is the library basically being attached with every project so that you can actually communicate with SQL Server. So let's just include that into our naming. So we just added that into using at the top so that we can reference SQL connection namespace straight away. In here, what I'm doing is I'm creating a public static class within products, a product class. That means I don't have to actually instantiate a product class, and I can get to this product get data method straight away without actually instantiate this class. And that static method will return me a list of products. So it will return a list of these classes. To that method, I'll provide a connection string to my database. Here we'll basically instantiate a new list, then using connection, SQL connection, and then connection string will open up a new connection. Well, we'll create a new connection, and here we will actually open it. It will open up a new connection to the SQL Server using so-called application pool, no, connection pool, but I'll explain that later. We normally, it's a really good idea to encapsulate everything in using, or when we use an SQL connection, into using. That means that even when we exit, when we exit without closing the connection, this connection would be effectively put in the application, well, in the connection pool as closed. So, for example, if I return here, this connection, basically to the SQL Server would actually be treated as closed or suspended, etc. But I'll explain about the connection pools because a little bit later as well. It's quite important to understand how they work, so we don't have to, so that you don't end up basically breeding the connections everywhere. And also the fact that you have to keep them closed. And it's a really good idea to do it as a snappy operations. Open a connection, do something, close it. All right, in here we've got SqlCommand. This is the stuff that actually does something. And it's also a good idea to encapsulate that into using as well. That's normally if we reuse the same connection further down the line. That means that our SqlCommand will actually get closed as well, so it will get disposed. So all the references to it will get disposed, and if we've got an active reader connection to it, it will get closed as well. So just to give you a little example, a little kind of meaning to why we actually have, well, it's a really good idea to encapsulate the SqlCommand into using as well. If we reason data, as we do here, so first of all, we actually instantiate SqlCommand with an SQL statement. So this SQL statement will give us everything from a product database, from a product table. Okay, we pass the connection to it, and then we are opening a reader to that SQL statement. So what's happening is that this command will get sent to SQL Server, it will get executed, stuff will get read back, and we will open up a stream, almost like a stream. We can treat it almost like a stream in terms of data communication. And SQL data reader here will be reading that stream row by row. Okay, so we open up this SQL reader, and then we basically, with this statement, start reading stuff until we reach the end of the stream. So we we just read row by row. And as we read row by row, we put every single element that we read into output. So output, add new product, and then here we're saying color of that new product would be reader column color from our data set that we're reading currently of the stream, and so on. Okay, so we put in all the rows that we're reading out of the data stream into our collection, and then once we reach the end of the file, we will exit, and then we'll go back, and then we'll close the connection, and then finally return what we actually collected in the output back to the color. Okay, so the reason why we have to encapsulate this into using is that if I try to reuse this connection, active connection, because I opened it somewhere here, for example, I'll go and define another command. I know that's right. Okay. That will fail because currently this connection is being occupied by this reader. So every time we read something from a data set, we have to close it. But in case we actually errored out somewhere, or we forgot to close it, and we're supposed to forget to close it, then any other subsequent statements that we issue using this active connection will actually fail because we currently have the active reader. So, but if we actually encapsulate this into using, then that reader will get closed automatically once we actually exit about there. So we can then reuse this connection down here as well. So it's just a little bit of safety, and also disposes the object correctly with using. Do you know about disposing the object? Do you know how much do you know about like .NET at all? I mean, I know that several of you do. Everybody else who is not in development, nothing. Okay, if I'm going too fast over this, or you don't understand something, then just basically stop me and ask me to explain further what I'm doing. Okay. All right. So we've created this class called product that will actually contain all our product data, and one method that will return all the products. So let's actually get this data out. So I'm going to go to my WinForm application that just holds, contains just one form. In Toolkit, I'm going to create a button, right? Just a little button. Give it a little test, load, and on click, I want to call this method. But first of all, I need a connection string. Okay, right. In this specific example, we're just going to keep the connection string as a string in our application. Nothing really fancy. But normally you wouldn't do this. You would keep this in a configuration file or in some kind of config class that you can basically define somewhere, or you would keep it in a connection store or password store or whatever, somewhere where it is quite configurable. You don't keep the connection string in the code. It sounds very obvious, but it's very tempting to do it in a lot of cases. Okay, the connection string to the SQL Server looks like this. So we specify the data source, which is our SQL Server. So this is our data source, server name. Basically, this is how we access the server. So if it was a server on somewhere on a network or on the internet, that will have the IP address and then an instance name, or some ways of actually reaching that server. Then we specify user ID. And then for user ID, I need to actually go and create a user, because I think in this database we don't have any users that can access it. I'm just going to make sure that our SQL Server is enabled for SQL and authentication and Windows authentication mode. Do you remember what are those?
Windows authentication is when you log in, basically, when you start up the PC.
Yeah. So SQL Server basically means that we can create a user with login and password individually. And that server authentication means that we can actually connect with that user. Okay. I need to restart this. Yes, please. Okay. So I'm going to go and create a new user, and we're going to call it user test. Give it a password, test. And what do we need doing? What do we need to do next?
Give him permission to read.
Yep. We have to take this user, because currently we just created a login to the server, but currently it's not a user of this database. So we have to go and give this user allocate this user to this database. And for the sake of it, for now, I'm just going to give it a membership of DB owner, meaning that we can do anything we want in that database. But going forward, you wouldn't do that. You would create a user that is actually responsible for doing a couple of certain parts in database, like we previously looked at the database schemas. So you create a user, then log that user down completely, so don't give him any permissions, not to read, not to write, anything like this, and just give him like the schema that you want that user to work with, or a set of stored procedures or a set of tables that they are allowed to execute under this context. But for now, for demonstration, this is DB owner. You can do anything he wants. Let's jump back to our C# application, and here we're going to put user test, password is test, and the next thing is initial I think it's like this catalog. Initial catalog is the database that we connect into straight away. I mean, once the connection is opened, this is the name of the database we will actually connect to. So that's going to be our database we're connecting to. Cool. Okay, so that's our connection string. This is what we're going to use to actually connect to the SQL Server. Next thing is we will create a list. Those things are basically define the type of that list. So it's a type of business logic stuff, basically. Now, before we do this, just remember, since we have 2 projects in our application, that will effectively compile into executable, this test app, because that's a WinForm application. And this is a class library, business logic. It will compile into DLL. So in order to use any methods within this business logic, I have to actually reference that library. Okay, we'll do this by going into referencing, add reference, and then we can just use the one, the solution referencing, meaning that we can see all the libraries that we have created within the project itself, and it will kind of maintain what gets built first and where those DLLs are being pulled from. So I'm just going to say, I'm going to reference business logic from my test app. In here, now I can actually start using those classes. So list, business logic. We have person folder in there, do you remember? Then was that in person? Did I put it in person? I did put it in person. Okay, let's move that into production. And also, because I created this class with its so-called namespace, you have to kind of read about namespaces and the basics of C# on your own. Okay, I'm just going to change the namespace so that we can access it. A namespace is basically just a path, how we actually get to that class. So in here, in production, product. Okay, so we're creating a list of this type. Why am I going for persons all the time? Okay, products, and then we can call that method that we've created to retrieve the list of products. It's right there, product get. Pass the connection string to it. And that's it. Okay, let's set up a breakpoint, so we can just do it like this. Set up a breakpoint, which means that when we hit this line, the execution will stop, and we can point at different variables and see what they actually do, and we can so-called debug it. We'll execute that and click load. Now it hits that point. If I F11 into it, it'll start stepping through what's actually happening. So okay, and if I F10 over this, we can step through this code line by line. So first of all, we created this new list of products. And then we opened up a connection. Let's see if it opens. It doesn't open because user test is login failed for user test. Okay, well, let's test the fact that we've got the right connection string. User test, and now password is test. Connects, opens it up. So it's all good. Messed up somewhere. Connection string.
But the sequence not correct.
User test, password test. Okay, yeah, password is wrong. Should be T. Small t. Just remembered, I can't use F10. Okay, but while we're debugging, just a little note, for example, because a lot of people actually don't know this kind of stuff. While we're debugging, we can make inline code changes. So while we're actually stepping through it, we can start writing our code and executing it. But we can only do that if our project is configured for debug mode and if it's only in x86 target platform. x86 meaning 32-bit system, and 64 means that 64-bit system. Any CPU means that it's kind of compatible with any CPU, whether 32 or 64. These days we compile everything as any CPU just for the sake of it, but any stuff that goes on the server, any web services, or, well, any Windows services, we compile that as 64-bit application, so the server knows that it can use more than 2 gig of RAM and some other stuff. Okay. Let's reconfigure our active solution platform to 86 so we can make inline changes in code. And I need to go back into our connection string and change the password. Okay. Uh-oh. All right. So by code changes, I mean I can start writing my code right here. Write line. Hello, Nick, example. Oh. And then we can do more stuff. I don't have message box on that. Anyway, so let's step through this product get while we're in the connection string, while we're in the connection. So connection opens up correctly, then we provide in the command that we actually going to be executing on the server, done, and then we, by SqlReader, we actually execute that command on the server and start reading data back. There you go, blink, opened up. At the moment, that reader is all it's holding. It doesn't hold any data. All it's holding is the fact that it's like a handler on the stream that reads the data. So we actually have to read it with while and read. So reading that, and as we read, so this is our first record. We can kind of go into it somewhere. There is somewhere deep inside, hell knows where. Yeah, basically. What?
Results to the bottom.
What is actually going to get all the rows there? Oh, that's our read all, read to the end.
Yeah, so executes it.
Okay. All right. That'll of course fail because we expanded it, didn't it? Yeah. Anyway, I'll explain in a second what just happened. I just want to walk through. Okay, so as we read the data, we create a new object with this statement here, new product, and assigning all the object properties to the values that we read from the SQL Server. And as we create them, we can move your mouse over this list type, and we can see that there is a new element in that list type, business of type production product, and it's got these properties. So this is our first product in our database. Keep doing that until we reach the end. Okay, but let's just basically let it run through. Right, and at the end, we read 504 rows out of the database, and that's where they all are. I keep wanting to press that button. Okay, so that's the list of our products right there. So we can now do something with them. So for example, if we in a WinForms application, we can take that list of products and we can put it in a grid, or we do something with them. I don't know, output them into a file, whatever you need to do. Okay. All right, let's extend this business logic class a little bit further. Oh yeah, just to explain what happened before is, do you remember I said that all we're doing with the data reader, we open up a handler to read the data row by row. When I was there, let's do it again. Okay, when I was there, result view say it says expand this result view to see enumerables, it's not currently available because we haven't read all the data back from the server yet. You know, we're currently in the first row somewhere. So I think if we step through it, we're going to see a result view. No, we don't. Anyway, if I click this thing, it basically what it will do, it'll read everything to the end of the file. And that means that we're going to move our handler point to the new record somewhere. Basically, we're going to be at the end of the file, and we're trying to read it there at the moment. So that's what happened. That's why we thrown the error previously. So as you read from the data reader, you can't go up or down, etc. You just read as the stuff comes along, put it somewhere, and then do something with it. All right. So yeah, as I mentioned, let's create a. So that's how we can read the data using select statements, so we can use views. In fact, we can execute any sort of command on SQL Server, insert, delete, update, or we can create a batch statement that does lots of things and just throw it in SQL Server and it'll do everything as a batch. That's effectively a command. It's exactly the same, pretty much, as writing stuff in here and executing it. So you write stuff, you execute it. This is almost like a data reader that reads all your data back, and we have to then go through row by row and do something with it. We can do some insert statements, delete statements, and also supply them as a command into our SQL statement. Okay, if we do insert commands or update commands, things like that, we don't need to read anything back because we just, updating data. There's nothing actually being returned. In that case, we use a command non-query execution. So we just throw it to the server and say, okay, do it. Once you've done it, let me know, and we will continue further down. There's another one that is called execute scalar operation, which I will explain now. And there's things like execute XML readers if we actually read XML, if we need to go to specific nodes and things like that. So there are several, multiple ways of actually executing things using SqlCommand and data readers. Okay. Right. So let's create another method. This is going to look like, in fact, I will first create a store procedure. Okay. In our database, I'll create a store procedure called product add, and that will, guess what? It'll add a product to the database. And we're just going to provide name, product number, color. That will insert a new product into product production database. And I remember about auto-incremental fields as a primary keys. So because when we insert in data, we don't know what that key would be. So we need to insert it and get it back into our client application so that we can then insert all the reference and tables. Like, for example, if we need to insert stock level for that product, we need to get the ID of that product first. So that's what this store procedure actually does. We insert in data into product table. There's a product ID as a primary key, and it's auto-increment. When we inserted this, there will be a new global variable on SQL Server in this connection context called identity. And we can grab that variable and basically select it out of it. So that means that this store procedure will have a return. It'll just return one SQL cell, effectively one row, one column that will contain the new product ID. And that's called scalar value or scalar value. Okay, because it's singular. All right, let's create the store procedure, and now let's go back to our code. I'm just going to grab my code and insert this as a static method into our product class again. All right. As I mentioned before, it's a really good idea to keep some kind of meaning to your data classes, such as, for example, if I created a store procedure and I called it product add, let's call the method product add. And also the names of our store procedures, as you remember, I mentioned that it's a really good idea to reference what they actually do and what they do to what. So this store procedure does something to a product table, so I call it product. And then what it does, add. If I had something else that it did, like, for example, add and delete a previous product, and maybe I had this great idea to do that. So we put something like, and delete some other stuff. Don't worry too much about how Got it? Doesn't matter how long your store procedure names are, you know? There's a tendency for developers to name, variables and store procedures with very weird names, like, baby names, etc., or make them very small or short, or like use abbreviation. Instead of add, they put add, then this, then that, then something like this, then that, and like this. Because they know what it means. It looks nice and very cute and small, etc. But it doesn't mean anything to other persons. So name your store procedures, name your methods and classes in your data adapters so that it actually means something. Otherwise, it's just going to be a pile of crap. And don't name them like this, add product. Because everything starts being named with add, it's very difficult to sort them. Or get, for example. I'm saying don't do that because that's exactly what we did in WinWorks. And now it's a giant mess. Okay, so coming back to our code, in product class, we've got product add, and what we're doing is, again, it's a static method, meaning that we don't have to instantiate a class in order to call this. It's just a piece of code that we can execute, that we can reference within a class. Okay, and in that method, we're going to pass a product class. And this is we can encapsulate all the data that we're going to be inserting. Open up a connection, again with the connection string that we passed in, and then we initialize instantiate a SqlCommand, and the name of basically what that command, the command text, I think, it will contain the name of the store procedure. Notice that in the name of store procedure, we have to specify the schema name, unless the user is bound to a default schema. Then it wouldn't know what that's. If we just specified it as product add, it wouldn't know what that is. You have to specify a schema because by default, user test is looking at DBO schema. Okay, if this store procedure was created under DBO schema, we don't need to specify the schema name. We could just do this. But because it's not, we have to specify the schema name, pass the active connection to it. The next thing is we have to specify what kind of type of this command is. So we have to say command type, and that it's a store procedure, then pass the variables to it. So we create in this command, create a parameter, then we could do something like add with values, name of that parameter, and then the actual parameter itself. Then finally, we have to execute it. But because we don't want to open up a reader and read the data, we only have one row, one column out of it. That's why we can use execute scalar. Scalar means that it's going to take the first row, first column out of the output, and that's the value it will return as an object. This product ID out, this is where it's going to return it. Then we evaluate whether this project is not null or not DB null, meaning that we actually got some data back. And then we assign it to the product class that's been that's been supplied, and then finally return it as well. So that's how we actually get back the new product ID. All right, so let's actually execute this now. Create another button. Button. Screw it. Just call it button 2. All right. Okay, let's play business logic, production, product add. Then we have to specify, the new product that we're going to be adding, but we only need to define like a name, color, and product number well, product SKU or product number in there. So new product. This basically means that we're going to create a new product with default construct, meaning that all the variables that are within this product will just take default values. And then by doing this, we can construct the class as well. So we can define all the properties of that new object in code. Okay, color equals black, name something like that. Product ID, we don't need to specify that because it will get returned to us from the SQL server. The product number is this. Ping, ping. Connection string is our connection string, and that's it. Okay, so that will insert new product. What am I doing? Keyboard, Novatech keyboard. Okay, new, well, it will return a new product ID. So we need to grab that product ID. So new variable, new ID equals that method that we're executing with this product that we're going to be inserting and our connection string. Then what we can do is we can output a message box saying string format, new product ID is this, and then we supply that, new ID. Okay. You following that? Okay. And then basically what we're going to do is we're going to do exactly the same as we did here. So first of all, we insert a new product, and then we're going to retrieve all these new products, and then we're going to see if that new product is inserted. Just for a laugh. Well, just for a laugh. It's not very laughing matter. For demo, I suppose, because it will get inserted here. If we got its new ID, it was inserted. But then we can just basically retrieve that new product, and then we can find it, and by, let's say, product number. So that was our product number. If it's not null, I'm going to output message box, again, string format. Right, I need to go and find it again, just be daft, and name of the product. Okay, so here I'm going to go and find, well, get all the products out of the database. Then here I'm going to go and find the product in that big list where the number is that. And then I'll output a message box where I'm going to find exactly the same product again with this thing, this is called lambda. And what it is just basically an iterator through every single element, but just written nicely. And then output its name. Well, let's give it a go. Set a breakpoint there. Execute. F10 is forbidden. Okay, F11. Step out, step into F11. Okay, and open up connection string, create a SqlCommand, pass all the parameters to it. So this is the new parameters that came from this class that we supplied into this method. Execute it, and we've got our output. So the new product ID is 1000. Step into it. It's not equals to null, and it's not equals to db null. Therefore, we will assign it to the class that we got supplied, and we will then also return this value to the caller, this one. So we've got its new ID. Call a message box, new product ID is 1000. Then we'll load all the products from the database. It's 505 now. Find that product, it's in there, and this is the new product that we inserted. Cool. That is basics of it. Okay. So that's primarily how, the very low level how we normally interact with SQL Server. Okay. But that doesn't mean that, as developers on a day-to-day basis, we're doing exactly this. It doesn't mean that we read the data row by row and we insert the data, etc. We normally have a lot of wrapper classes that simplify the whole thing for us. So for example, we've created our own wrapper classes here. That's called data helper, I think. That what they do, instead of us writing this whole thing, like creating your output list, blah, 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 open up a connection string, and then read the row by row, read it, and then assign it to every single property in this class, etc. We literally have wrapper classes where you specify this string, saying this is a command, just a normal batch, SQL, for example, and convert that result into a product. And it does it all automatically, basically. So we've written the code that that does the reflection, which means that it knows what type we need to return, what sort of data we have, puts them together, and outputs this stuff to you. We've got things that allow us to execute store procedures, get single results out. So a lot of helper classes that wrapped all this base functionality around, and we can interface with a lot easier. Okay. Also, for example, we needed to interface with a database. We have to create, for every single table, for every single data type, we have to create a class almost manually. So we have to go and say, okay, I've added a new table. I have to go and create a new class, and it's going to be called, I don't know, manufacturing, and so on. Yeah, takes a lot of time, especially if you've got very big tables. You have to go public. In fact, you don't go public, you go string, then internal method, I don't know, name, and then you have to convert that into get and set types. That's a convention. So you have an internal variable within the class, and then you have get and set methods. You have to define them, otherwise a lot of the code won't be able to get access to those methods, and things like that. So it's boring and takes a lot of time. So Microsoft has created this pretty great thing called the Entity Framework. We don't use it because I think it's a little bit restrictive. And if it's used incorrectly, which in 99% of the time it is being used incorrectly, it leads to a slow performance of the application, because the way the Entity Framework constructs all those classes, because it will literally do what we've just done for product. It'll do for all your objects in your database, for all the queries that you want to execute, for all the store procedures. It will do this, that what we've done at the moment. It'll do it automatically. The only thing that everything that comes in with the automated bit will generate a lot of crap that you don't need in the first place, because it just assumes that you do need it. Then the way it creates those statements, for example, the selection statements, etc., might not be the most efficient way. And there is a very limited, there's no limit in terms of how we can override different things and how we can optimize the query, so optimize the classes for better performance. Everything is kind of built in for you, and you start using it, and then you find out that once you get over a certain threshold of data, then the whole thing grinds to a halt. Also, Entity Framework creates classes that are unnecessarily heavy in memory. So again, that's a bit of a difficulty. So what we opted out is not to use Entity Framework at all, and it's banned for any sort of development, apart from Igor in Estonia, because he doesn't give a shit. And we basically do everything through, we write our own classes, represent the data adapters. We write our own methods. The only thing that we do is we use data helpers to avoid writing all this stuff manually, and things like that. What else can we mention? That's about it, I think, in terms of this is the basics of actually communicating with SQL Server. And yeah, hang on a second. Yeah, next week we're going to have a look at the entity framework, so we can compare entity framework with, writing it yourself. The reason why a lot of people say, entity framework is great, you don't understand anything, you're stupid, and things like that. Yeah, I know it's great. Everybody knows it's great. It's a very easy to use thing, but it, when it's misused, it's become horrible. And yeah, screw it. I think we're smart enough to actually write code ourselves. I just implied that entity framework people. Yeah.
Just a small question. You said that when we are using when we open a connection, it will dispose automatically, close automatically the connection. Why do you still use connection processing?
It's a good question. It's a habit. It's just a habit.
To make sure it will.
Yeah, to make sure. And basically, the rule is close the connection as soon as you don't need it. And that's it, even if we actually exited there. In theory, you don't need to close it there. But just for the sake of it, always put it there, everybody put it there. Nobody can explain why. But generally, it's so that nobody can start writing stuff there. They know this is close, just before it ends. That's it. It's almost like another predicate that says this is the end of it, right? But you don't need to do that. In fact, it doesn't actually close the connection string, the connection with the SQL server. What it does, it puts this connection in a connection pool on the computer. So every application runs in so-called process, and that process contains different threads. So different threads can do different things and blah, 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 this kind of stuff, the clever stuff. And each process contains, .NET framework hold so-called connection pool for all those, for a single process, where all the active connections get put. So instead of reopening the connection every time, because can you imagine negotiating the connection with SQL Server is quite an expensive process. You have to send it the encrypted password, username. That thing would have to go into its own local, list of users, compare that username, password, read its permissions, cache them, and then say to the client application, here's your session ID, blah, blah, this kind of stuff. So it is quite, computation is very expensive. So if we had to do this every time we connect to the server will be doing, logins most of the time. That's all it's going to be doing. So there is a caching mechanism for those connections. And what it is basically every time you open a connection, and then when it starts looking at your connection pool, is there already available connection in my pool? If there is one, it just uses that. If there isn't, it'll create a new one. So it'll do the whole negotiation. And instead of when we close this connection, instead of actually closing it on the server, it will put it in the connection pool. And it will remain almost as an open connection to the SQL server. So it knows its session ID, it knows who it is, etc. So I have no idea how it maintains the security of it. I hope it does. But that's the idea.
Both of it, using and exiting from using and using this line close connection, both will do the same.
Yeah.
Both will just kind of release the lock.
Yeah, pretty much.
For other processes to be able.
Yeah. So this connection will get put in the connection pool, and then another piece of code within your program only. No other processes can use this connection. Can basically, when you're doing exactly the same thing, it basically looks out by a connection string. If it's exactly the same as we already have in a connection pool, we'll just use that if it's got an active one. And the first thing, it will negotiate whether this session is alive or not. If it's not, it will recreate the connection.
Is it vital to clean up those connections with database? Basically, when we use a lot in one, let's say, go. When you're using the program, another program processes are using connections. A lot of connections are stored with the server because they're already negotiated. They will keep them somewhere.
Yeah.
Is there any issue when it comes to big, like storage becomes overcrowded? Let's say.
For SQL Server, that's overcrowded storage would be quite large, I would say. For your local connection pool, you can specify in the connection string. So there's a whole bunch of parameters we could put at the end. How many connections are going to be kept active in the connection pool? What's the timeout for those connections, etc. If the connection is in the pool and is not being used for a certain amount of time, it gets closed by SQL Server and by the connection pool application. Connection pool itself. So SQL Server maintains them all the time, and it will clean them up automatically. Yeah, you don't need to worry about that. Also, when you exit the process, because that connection pool is like associated, is like a bit in the memory that sits there, and when you actually close your application, it gets disposed. So when it gets disposed, it sends a session ID, session ID, it sends the application ID to the SQL Server with some authentication shit, and it will close all those associated connections. Only if your application crashed miserably, literally you press the power button and it just, those connections will, by the SQL Server, they will be like, yeah, they're still alive for about 5 minutes. They're not used, dump them, that's it. So it does it pretty efficiently. And for example, even in our multi-tenancy environment, we've got like a couple of thousand users using a single server. It's all right. I mean, at any given day, take a snapshot of the active connection pools, connections in pool, you'll see about 15 to 20 per database actively, there all the time. Any more questions?